Hey everyone, welcome to ALB programming lesson. In this lesson, I'll try to walk you through the jungle of information technology world and share my own opinion about how to program and how to learn to program based on my own journey and experience. Let's see what is programming. Here is the Wikipedia definition. Computer programming is the process of designing and building an executable program for accomplishing a specific computing task. If you're new to programming, this definition may not be very easy to understand. Let me explain a little bit. When we do programming, we pretty much design a program, we build a program, and that program must be executable. For instance, I've got a program here. It's named VirtualBox.exe. This program is executable. When I double click on it, it's executed and turned on, and I can use it. Now I'm gonna make another program within a few seconds. Just on the desktop, right click on the empty area, go to New, click Text File. I'm gonna rename it as test.exe. When the file extension is exe, Windows operating system sees it as an executable program. When you double click on it, Windows finds it not executable. So VirtualBox.exe is executable, but test.exe is not executable. Alright, we design and build an executable program. To do what? To accomplish a specific computing task. The task depends on what you want to do. For example, in this series, we've been developing a program to send emails to different students according to certain criteria or requirements. To be simple, programming is to solve problems. It's to build software to solve problems. Then how to program? Well, it's impossible to answer it with all details in one video. As far as I know, there are at least 20 million software developers in the world. Some of them might be doing the same stuff and others are doing the completely different things. For example, programming a job application system might be similar to programming a university admission system, but very different from programming for airplane signal systems. But generally speaking, we can pretty much follow a worldwide accepted process to produce software. That process is known as SDLC, Software Development Lifecycle. What is it? By the way, it can be an interview question during a job interview. Alright, there are a few phases in software development lifecycle. Some people would say 5 phases, some would say 7 phases, some would say 6. It doesn't really matter. Regardless of the differences, the intent of the SDLC process is to build high-quality software and solve problems. So I'll take this as an example and let's take a quick look at each of the 5 steps. The first phase is requirement analysis phase. During this phase, we sit together with a group of people and try to capture as many details of the requirements on the software as possible. It's pretty much like what we've discussed in the 4th lesson in this series, except that requirement analysis is often a teamwork. It's better to keep a document on what we've discussed. The second phase is the design phase, including graphic design and architecture design. Graphic design, is to design the appearance, layout, and user interface. Architecture design, maybe you have seen some block diagrams full of blocks and arrows. It's about user flow, data flow, process, and technical details. Well, during the design phase, we need to review the risk, the cost, time, limitation of the system, and even team capacity, and etc. After knowing the requirement and the design, we can start to implement. The third phase is the implementation phase. Development team starts to write code using appropriate programming languages. The next phase is the testing phase. The goal in this phase is to find bugs and defects and report them to the developers. The next phase is to deploy the software and monitor the product. If necessary, we have to fix some bugs and deploy again. During this phase, we maintain the product and make sure it works as expected. Alright, the 5 phases of software development lifecycle pretty much make up the process to produce software. As a programmer, you might be involved in all 5 phases, or a few of them, or just the implementation phase. It depends on the nature of your company, as well as the development team. You can actually search some job responsibilities even if you are not ready for it. For example, I'm going to Indeed.com and change country, find the city, type the job title, search. Here are a list of jobs. Click into anything you are interested in. Look, here are the job responsibilities. Here are the minimum requirements. Search a few jobs, you'll roughly know what you are expected to do. So, how to program? Short answer is, it depends on the company and job requirement and job responsibility. In general, we can follow the SDLC. Start with the requirement gathering and analysis, then design the program, then write the code, then test the program, then deploy and make sure the new program works properly. If necessary, you need to go back to the requirement analysis and re-examine each development process. In other words, the process of programming is pretty much breaking a big task down to smaller pieces, small pieces into even smaller pieces and deal with them, and eventually you accomplish a big goal. In contrast, the process of learning the program goes the opposite direction, especially if you're new to the IT world. Every time I would learn a small piece of code or a simple operation, and after a period of time, integrate the small pieces of code into a functional product. In the beginning, I would just find a tutorial and follow it to set up the tools and development environment like Eclipse, Workspace, VirtualBox. It's very important. You know what I mean if you watched my first lesson in this series? Then I would watch a tutorial, follow the steps, and try to write some small pieces of code, pretty much like what I teach you in the previous 10 lessons. Then I can take initiative and bring together what I've learned and kind of grow and combine those small pieces of code into a more complex program. Then I'll ask myself, what is missing? How to deal with it? And further grow my program. It doesn't have to be super useful production software. It's kind of like the 10th lesson in this series. In the 8th and the 9th lesson, we learned date and time in Java. In the 10th lesson, we learned if-else statements and applied the knowledge about the date time. Keep learning, keep applying, keep experimenting. Over the time, your program will grow and your knowledge will grow as well. Easier said than done. Let me show you how I can further grow my program in 10 to 20 minutes. Well, I've already learned to install the VirtualBox, in which I have a Linux virtual machine. Start it up. I have an Eclipse here. I didn't tell you how to install Eclipse in a Linux system for a reason. I packed up everything into one file for you to download and import. I've explained it in the first lesson. When I have my tools and utilities ready, I would write or copy and paste the Hello World program. Then on the basis of Hello World, I can learn some details in the programming language, like basic syntax. For example, in Java, you must learn about class. Then you can learn other data type like string, int, maybe long, date, and etc. Like here, we learned those in the 5th through 9th lessons in this series. Then you must learn if-else and for loop, while loop, no matter what programming language you will be using eventually. The if-else statement is like this. Maybe you will also be interested in learning the switch statement. Of course, it will take some time to understand the concept and try things out and do some experiments and digest the knowledge. Well, after knowing some fundamentals, I want to combine what I've learned into something a little bit bigger. For example, I have a program that just sends email. Here, I'm going to modify this program to make it able to send email notification. During the learning process, I won't consider too much at the beginning. I'm going to let the program just send out such an email, at this one. I'm going to change the subject to this. As I've learned in the previous lesson, I'm going to work on this method. I'm going to replace the parameter by what I've just copied. Next, I'm going to change the email text. Similarly, I'm going to work on this method and replace the parameter by whatever is appropriate. I'm going to copy this line. Of course, I can copy multiple lines, but there is a risk of copying some strange characters and thus causing problems. So, I'll copy line by line. Maybe I'll need to start a new line here. Let's see. Save the file and run the program. Program is terminated and no error has occurred. I'm gonna check my inbox. I see a new email. It looks like this. It's okay, but I want to start a new line here. Here and here. So I'll add a line feed here, here, and here. I learned the line feed, one of the special characters, in the 7th lesson. If you're new to programming, you might be slower, but you can eventually figure it out. I've restarted the program, check my inbox, got a new email. It looks better now, except here. I need to start a new line. So I'll put one more line feed here. See, I add one more \n, save the file, and run the program. Program is terminated and I'm gonna go check my inbox. It looks better now, but how can I improve this? Well, this text is static. The content is fixed and hard-coded here. There is no point just sending some static text with Java and using a whole lot of complicated tools. I'm gonna make it more dynamic, like the name, course name, schedule. They change all the time and they're supposed to be variables. So firstly, I'm gonna define some variables, string, course name. Let's assign a value as well. The value is opening quote, Java, and closing quote. String, student name, equal to opening quote, Max, closing quote, and semicolon. String, classroom, equal to the thing. Alright, we also need a schedule, but the code is a little bit complicated. Let's copy some pieces of code from the previous lesson. Here, we need to copy this part. Copy it. And paste it here. What else do we need? I have a date format through which I can parse a date object. By the way, this is just a comment. It doesn't do anything. Back to the code from the previous lesson. Let's also copy this line. Paste it here. You'll see an error. Here the quick fix. Truth is surround with try. Truth is surround with try cache. Well, I've added pretty a lot of things. I want to see if there is any change in the result. Save the file and run the program. Okay, nothing's changed. At least this classroom is supposed to be like this. Why isn't there any change? Look at these variables. I have defined them, but I've never used them. See? This name, it's still the static text. I'm gonna replace it by the variable. How do we do it? We learned this magical plus sign when we were learning the string. Do you still remember? It's string concatenation. The plus sign must be outside the quotation marks. The plus sign must be outside the quotation marks. This blank space doesn't really matter. It doesn't matter how many blank spaces you type. Alright, type the student name. And one more plus sign. Save the file. And run the program. Program is terminated. Let's check the inbox. Let's go back to the inbox. Still no change. I'm gonna change the student name to, let's say, Maxwell. Save the file. Run the program. Now I'm gonna check the inbox. See? The name has changed. See? Similarly, I'm gonna use this variable, this one, and this one, and make the email content more dynamic. Change the course name, and change the schedule, and change the classroom. Save the file, and run the program. Back to the inbox. Alright, I see an incoming mail. The content has changed, but this is not what I want. You don't want such an email, do you? We use the variable values, not the variable names. So we need to put this variable outside the string, outside the quotation marks. Like this. Let's also put the schedule outside the string. But here's an error. Schedule cannot be resolved as a variable. Why? The variable that I'm trying to use is schedule. But the one I've defined is someday. For me, they are the same, but not for the computer. So I'm gonna use someday instead. I've changed it, but I still see this red underline. The error message is the variable is not initialized. Initializing pretty much means assigning a value. But I did assign a value here. Alright, I declared a variable someday here and assigned the value in the try block. If the code in the try block fails, then the code in the catch block will be executed. I did the initialization only in the try block, but not in the catch block. So I'll also assign the value in the catch block. Not working? You know, someday is a date type object, and I am trying to assign an empty string. It will not work. I'll assign null instead. Error is gone. The same with here. Error is gone. And here, we need to put this variable outside the string, outside the quotation marks. Got an error again. It's because I just deleted the quotation mark. You know, quotes always exist in pair, like parentheses and brackets and curly brackets. So I'll delete the quote. Error is gone. Save the file. Run the program. Program is terminated. I'm gonna go check my inbox. The content has changed. You see it? See? So to recap, what I did to make the email content more dynamic is pretty much combining the static text with the variables using the plus sign. In addition, you'll find these special characters pretty useful. Alright, this is pretty much how I grow my program, adding a little piece of code every time. Even a teeny tiny change like replacing a static text with a variable, comparing the results before and after change. Over the process, I can experiment with things, gain experience, and even learn new stuff. I learn skills pretty much in this way. Learning small piece every time, try to put the knowledge into practice. Things will build up over the time. So what else skills do we need to become a programmer? From the software development lifecycle, SDLC, and many job requirements, we can see programming requires several types of skills. Not just programming language. To name a few, communication skills, planning skills, problem-solving skills, analytical skills, and of course programming languages. So, how to learn those skills? Short answer is learn the basics and apply what you've learned to your work. Maybe you already learned arrangement and combination in your math class, or you already read some books on communication skills. Now the next thing is to apply your knowledge to your work or job and solve some real-world problems, plan an event, organize an event, make things happen. If you can't find a job or you don't know what to do right at this moment for the time being, I encourage you to volunteer in a local organization or volunteer in a church. Then look for an opportunity to plan an event or organize an event, big or small, talk to people and help solve problems. Over the time, you will have some chance to meet more experienced people who provide you with some guidance. And in the long run, your communication skills and problem-solving skills will go to the next level. This is pretty much how I have been improving my non-coding skills. The same with the coding skills. I learn the basics, simple operations, simple code, and add things up to my small program and apply my knowledge to my work. Alright, let me give you a brief summary. We've discussed what is programming. It's a process of designing and building an executable program for accomplishing a specific computing task. We've also discussed how to program. In general, we can follow SDLC, analyze requirements, design the UI and design the system architecture, write code, test the program, deploy the program, and make sure the program works as expected. If we say programming needs to break a big picture down to small doable tasks, then learning to program is to start from small things and mix them up or build them up into something bigger. That's it! I hope you learned something. Thanks for watching and thanks for your support. I'll see you in the next series. Peace.